Hello everyone, welcome to our final exam review. So this is it. This is the end of the semester and we are getting ready for our final exam. We're going to see two standards on the final exam. We're going to see a standard covering solving equations, and then you're going to see a second standard covering solving inequalities. So this review focuses on solving equations. Alright, so our goals for this review: we want to solve multi-step equations, we want to use the distributive property to help solve equations, and we want to understand what a solution to an equation is. Alright, so you might remember these from a previous lesson, but these two slides right here kind of give you all of the little tips and tricks and things like that to help you solve equations. So you got your step-by-step over here and a nice worked out example over here. Alright, so if you need to read through these again, that's fine. Remember, when we're solving an equation, our goal is to find a value of x that makes this entire statement true, right? So whatever number I come up with, I want to be able to plug it in for x and get a 3. Right? So I would plug in some number and get a 3. That's how I know I found the right solution. Alright, the way that we do that, we simplify, right? So if there's anything where we need to distribute or combine like terms, we're going to take care of that first. Then we're going to move our variables to one side and the numbers to the other side using opposite operations. Alright, so for instance, we see a minus 9 here. We might end up adding 9. And then whatever we do to one side of the equation, we must do to the other side of the equation to keep it balanced. Alright, so let's try one out. Let's solve an equation here. This one's an easier equation. We don't see any parentheses. We don't see any like terms that we need to combine. So really, this is just a matter of moving everything that's not an x to the other side of the equation. Alright, and I like to start with anything that's adding or subtracting. So I'm going to start with this minus 9. So I'm going to do the opposite, which means I'm going to add 9. And whatever I do on one side, I got to do on the other. Right? So when I add 9 on this side, the 9's will cancel each other out, leaving me with just a 12x. And then over here we get 3 plus 9, which is 12. Right? Then we got to move this 12 that's attached to the x here. It is attached by multiplication, right? So these two things are multiplying. So if I want to undo multiplication, I have to divide. That is the opposite of multiplying. And whatever I do on one side, I have to do on the other. Okay. So 12 divided by 12 becomes a big 1. It cancels out, leaving us with just an x, which was our goal. And then over here, 12 divided by 12 is also just 1. Right? And now we can see our solution, so x must equal 1. Right? And if I were to take that 1 and plug it into my original equation, let's give it a try. So we would do 12 times 1 minus 9. Right? 12 times 1 is 12. 12 minus 9 is 3, and that is what we wanted, right? Remember, we wanted to find a value of x that made the statement true. So if I plug a 1 in there, I get a 3 out, which is exactly what we were looking for. All right, let's try this one. It's a little bit more difficult because we see some parentheses. So this is a situation where we need to simplify a little bit, right? We want to get rid of those parentheses. The way I like to think about it, I need to get this x all by itself, but it is trapped inside of these parentheses, so I need to get it out of the parentheses, and the tool that we have to do that with is distribution. All right, so I can take this negative 5 and I can distribute it to each of these things inside of the parentheses, and when we say distribute it, we mean multiply. All right, so negative 5 times x is negative 5x. And negative 5 times positive 4 is negative 20. All right, so remember, when you do negative times a positive, that's a negative. If this were a negative, like a negative times a negative, that would turn into a positive. So make sure you're paying attention to your sign rules when you do that distribution. Now we still have a minus 45 on the right hand side here. So now that we have gotten rid of those parentheses, we can start moving things from one side of the equation to the other. All right, so I'm going to start with any adding or subtracting that I need to do. So I see this minus 20 right here. The opposite is to add 20. All right, so the 20s will cancel on the left hand side, leaving me with just a negative 5x. And we come over here, negative 45 plus 20 is going to be a negative 25. And if you get confused with the negatives and the positives, use your calculator. Right? We're not stopping you from using a calculator, so whip that thing out and plug in the numbers and make sure that you're getting the correct the correct sums at the end. Okay. So now we've got a multiplication here. I got to get rid of this negative 5. It's being multiplied by the x, so I want to undo that multiplication, which means I need to divide. So I'm going to divide by negative 5 on both sides. The negative 5's cancel, become a 1, so it leaves us with just x, which is good. And then over here we've got 25 divided by 5, and it's a negative divided by a negative, so it's going to become a positive number, and 25 divided by 5 is just 5. All right, so it'll be a positive 5. This is our solution. If I were to take this 5 and plug it in for x and calculate, I would get a negative 45 out. All right, let's keep going. All right, getting a little bit more complicated, right? So we see a parentheses. We also see this number on the end over here, so we might have some combining of like terms that we need to do. Well, let's see what happens. I'm going to start by trying to get rid of those parentheses. So I'm going to take this negative 3. I'm going to distribute it to each term inside of the parentheses, right? So I do negative 3 times x, which is negative 3x. And then I do negative 3 times positive 2. That's going to be a minus 6. And then we still have this plus 6 on the end. Now, a common mistake that students make is that they try to distribute to the 6 here on the end. That would not be good, and that's because that 6 is not in the parentheses. So it's not being distributed to. You only distribute to the things inside of the parentheses. And then this is all equal to 6. We got a lot of 6's going on. All right. So now I take a look at my expression. I notice these two things right here. I can combine those, negative 6 plus 6. I can actually do that because those are like terms. They are both constants, so we can always add together constants. Other like terms, they would need to have the same variable raised to the same power. Okay? So let's combine those. Negative 6 plus 6 becomes 0. Right? So these two guys right here, they add to become a 0. All right, so all that's really left over here is a negative 3x. If you want to write negative 3x plus 0, be my guest, but you don't really need to. All right, negative 3x plus 0 is just negative 3x. All right, and then I take a look at this thing. I see a multiplication here between negative 3 and x, so I'm going to undo that multiplication with a division. All right, so I'm going to divide by negative 3. Those cancel, leaving me with 1x. And then 6 divided by negative 3. All right, so we have a positive divided by a negative, so I know it's going to be a negative answer. And then 6 divided by 3 is 2. There's my solution. Okay. All right, let's try another one. Again, a lot of things going on here as we progress through this review. We notice the problems are getting a little bit more complicated as we work through that, but that's okay because we're not really using any skills we haven't already used before. All right, it's just we're using them more times. All right, so I see some parentheses on both sides that I need to get rid of here. So I'm going to use my distributive property again. I'm going to distribute this 7 to the x and to the 3. All right, so 7 times x is 7x. 7 times 3 is 21. And then we still have a plus 2. Right, and then I'm going to go over to the right hand side. I have to do the same thing over here. I have to distribute this negative 3 to each item inside of the parentheses. So we're going to get a negative 3x, and then negative 3 times negative 2 is a positive 6. That's a good opportunity to see that sign change rule. Negative times a negative is a positive, and then we still have this minus 9 on the end. Okay. So now I'm noticing that I have some like terms that I can combine. So over here we have this 21 and the 2. Those can be combined because they are both constants. And then over here in this equation we have a positive 6 and a negative 9. Those can be combined. Okay. So I'm going to go ahead and combine those. 21 plus 2 is 23, so we end up with 7x plus 23. And then over here, if I combine a positive 6 and a negative 9, that's going to combine to become negative 3, right? If I add those together, we get negative 3. So we've got negative 3x minus 3. All right, now this is a part where students tend to start going wrong, and that is because they're not sure what to do when they have an x on both sides, right? In all the problems that we've done so far, there's only been one x on one side. Now we have two x's, one on each side, and what we need to do is pick a side to gather our x terms on, right? So anything that's got an x, we're going to either put it on the left-hand side or we're going to put it on the right-hand side. That way we can combine them. Okay, so I'm going to choose to put my x's over here on the left-hand side, and what that means is I need to move this negative 3x over here with the 7x. Okay, so I look at this negative 3x and I say, well, it's a negative 3x, so what I'm going to do is I'm going to add 3x to both sides. So I'm going to add those. All right, whatever I do on one side, I got to do on the other. And this effectively moves that over here to the other side, right? Because these are going to cancel. So the only thing left on the right-hand side is that negative 3, right? So that negative 3x, it's no longer over here. It's now over here as a positive 3x. And I can combine it with the 7x, right? I can do 7x plus 3x. Well, that's 10x's. Okay? And then we still have this plus 23. All right. Now I'm going to take this plus 23 and I'm going to move it over here on the right hand side so I can combine it with the negative 3. So I'm going to subtract 23, right, because that's the opposite, and whatever I do on one side I have to do on the other side. So the 23's, they cancel out. All that's left is a 10x. And then over here we've got negative 3 minus another 23. Well, that's negative 26. Okay. And then the last thing that we got to do to get x by itself here is get rid of this 10. Okay, so this is being multiplied by 10, so I'm going to undo that multiplication by dividing by 10. Whatever I do on one side, I got to do on the other. 10's cancel. X equals whatever this is. So I'll pull up my calculator. We can get a decimal approximation here. So we're going to do negative 26 divided by 10. And we get negative 2.6. I probably could have done that in my head, but I was lazy. I used the calculator, and that's okay, because you're allowed to use a calculator too. All right, so there's our answer. If I were to take negative 2.6 and plug it in, we would have gotten a true statement. All right, last problem here. Notice this one is very different from the other equations. There are two variables here, guys. There's an x and there's a y, so make sure you read the directions. You need to know which variable to solve for. So we are solving for y, and what that means is we need to get y by itself, right? So anything that's not a y over here, the 2, the negative 3, the x, all that stuff needs to move over here. All right, so when we solve for something, it means we get that something by itself. Anything that is not a y has to go to the other side. All right, the other big difference about this is that we're not going to get a number in the end. Instead, we're going to get an equation. Not just any equation, but an equation for a line. All right, so let's see how this works out. So like I said, anything that's not a y needs to move over. So I'm going to start with this negative 3x. All right, the opposite would be positive 3x. I'm going to add 3x to both sides. Right, these cancel. Now all that's left is 2y. Now over here, this is where students make a fatal flaw. Right, this negative 6 and this positive 3x, they are not the same thing. They're not like terms. I cannot combine those. All right, so the best that I can do is write this out as 3x minus 6. Right, so my negative 6 is still there, and my positive 3x is right here. So both terms are still over here. I just can't put them together because they're not like terms. So I just have to leave it like this. Okay. Now last step here, remember I said anything that's not a y needs to go. So this 2 needs to go. It's being multiplied. So to make it go away, I need to divide by 2. And whatever I do on one side, I have to do on the other side. Now this is where students make their next fatal flaw, is that they only divide one of these things by 2, but you need to divide both things by 2. The entire side has to be divided by 2. Okay, so whatever you do to one side, you have to do to the entire other side. All right. Now the 2's cancel, so all that's left is y, which is what we wanted. And then I'm going to leave this as 3 over 2x. Just going to leave it like that, okay? I know some of you might be tempted to put a 1.5x there. Don't do that, because we need to find the slope, and this is a much easier way to see the slope when it's written as a fraction, okay? Now over here, you can go ahead and divide this. Negative 6 divided by 2 is negative 3, okay? We are done. We have solved for y, so this is our answer when we solve for y, right? But they're asking us some other questions here. All right, they want to know what the slope is. So if you recall, we learned about this format for a line, y equals mx plus b. And if you notice, when we solve for y, we actually got into this form, y equals mx plus b. Right, so the slope right, is represented by m, it's the number in front of x. Well, here it is, 3 over 2. Right, so I've got my slope. And then the b value represents our y-intercept, which is right over here. That's the -3. So I write that as a coordinate. It's going to be 0, -3. Right? Remember, y-intercepts always have an x-coordinate of 0. Okay, so now I'm going to go plot my line. I can start at the y-intercept. So if I go 0, -3, I plot my point, and then I use my slope to tell me where to go. Okay, so remember, this is rise, and this is run. Okay, so if I have a +3, that means I'm going to go up 3. So I go 1, 2, 3, and then the run is a +2, so it means I'm going to go to the right 2. 1, 2. So my next point will be right here according to my slope, and then I draw a line through those 2 points. Trying to drag that line so it's a little bit more accurate. I think I can get it. There we go. That's close enough. All right, so that is our line that is represented by our equation when it's solved for y. That's a line. All right, guys, that's all we needed to cover for our final exam review when it comes to solving equations. I hope you found that helpful. I would give the practice problems a try and make sure that you can do it too. If you have any questions, let us know in the Zoom chat. Have a great day.